Hello, I'm the Department of Electronic Convergence Engineering, who will be in charge of 17th Kwix presentation in 2021. We conducted a study on the subject of FMCW laser-based human motion estimation and identification research. The table of contents will proceed in the following order. First, it is a simple introduction to the study. We conducted a study on the subject of gait recognition, which correspond to behavior characteristics among biometrics. Algorithm and system were constructed to identify individuals based on the research of measuring pedestrian gait with FMCW laser, microdoppler, then estimation pedestrian speed and stride displacement, and analyzing gait pattern. The FMCW laser used in this study is IWR-8043 laser from Texas Instruments. The center frequency of IWR-8043 is 77 GHz and has a bandwidth of up to 4 GHz. Since it takes a long measurement time to measure the gait of pedestrian, 128 chirps per frame, 128 frames, or a total of 60,384 chirps were transmitted and received in the initial system that transmits signals for a short period of time. This part was adjusted using TI's MMA program as shown in the picture on the right. Next is the experimental process. The experimental emblem chose a relatively large place to reduce the reflection of laser signals on the walls, other than the target as much as possible. Pedestrians worked about 10 meters from the laser, and a total of 4 situations were given. First, the situation of working fast. Second, situation of working normally. Third, situation of working slowly. Fourth, the situation of working while looking at the cell phone were given. Thus, a total of 13 people, 65 data were collected. Through these experiments, raw data that has not been processed was obtained from the laser. In order to visualize this data, first of all, 2D FFT was conducted through MATLAB. It obtained range velocity information through the process of converting raw data into range amplitude data from the FFT algorithm. That is, it chirped into range amplitude data, and then draws range levelity FFT in order. The information obtained is shown in the picture on the right. This data allows you to check the change in speed and distance. We converted range Doppler data into a time velocity axis because we need to know the change in speed over time for gait recognition. As a result, we were able to check the speed change over time like the red line in the picture on the left. Through various assumptions and experiments, we confirmed that the speed change while working occurs when stepping on the foot, and then the data smoothing process was conducted to remove abnormal values in the red line graphs and obtain information such as cycle. We curved using Fourier 8th order function, and the result is shown in the picture on the right. In order to equalize the arrangement of the data obtained earlier, it was rearranged based on the first peak point of the sine wave, and the total travel distance of pedestrians was obtained through time range data that went through the MTI filter. Through these result values, information on pedestrians' stride, travel distance, and speed over time was obtained. We use MATLAB's SVM classification learner to learn this data in machine learning. SVM is an algorithm that classifies data through margin maximization, and in this study, it was used to specify individuals in measurement data, excluding the three of us. 10 participants participated in the experiment 5 times each and put this data in the learning data to learn. After that, we recruited each of the 2 experimental data that did not give any circumstance to each person. As a result, putting this data into a training model earned 81.5% accuracy was obtained. In this study, we proposed and measured a human body classification algorithm based on the latter, and the result we were able to obtain 81.5% accuracy. In this study, there were problems with the lack of characteristics used in the classification and the low distance resolution compared to the human body. But this problem can be solved by classifying the motion difference between the arms and legs as featured point by increasing the number of people for learning, optimizing machine learning algorithm, and expanding bandwidth. Thank you.